So
Is it hard?
it's not hard. It's just maybe you never see that before. Okay. So the definition, differential equation.
What is that?
A different equation is an equation relating to a function and its derivative. They both have function and they both have derivative. Okay? So I'm going to give you a sample.
Angle?
Whoa.
Is it what? Differential equation?
Huh? The parts implicit derivative. That means you're taking the derivative both sides. But this one you're gonna solve it. Huh? You've seen that before, right?
On the quiz of doom? On the quiz of doom?
The first one. Mr. Doza came in and he did.
What is that?
Oh.
What is it called?
Doom?
Doom?
The quiz of doom, yeah.
The quiz.
Oh wait, we did that.
The quiz of doom. Like this? What does that mean?
Mr.
Like-
there was this one quiz you gave us about implicit differentiation
Like-
and we were all like dying.
Like the quiz of horror.
That makes sense.
Oh.
Really? I just knew we were dying and I was like, so yeah, we did that. He went. Oh, the quiz for both of you.
Guys, don't forget about doing
He can hear my ear.
Okay. In this question, they ask you to write back the function. Okay? Remember, before we learned about implicit derivative. When you take the derivative of both sides, right? And then you solve for dy over dx. Remember last year? Right?
Kind of.
Last year, okay. D square x. Last year, this is the one on last year. I give you like y square x plus 3x square cube equal to 2y. And solve find dy dx. That's what we done last year. Implicit derivative. Does it ring any bell from last year?
No.
Implicit derivative, no? All gone?
Oh yeah.
Implicit derivative. I give you something like this. They both have y and x and ask you what is dy dx. You take the derivative both sides, right? And then you isolate the dy over dx. Now this one is just go backward, and they call differential equation. Go backward mean I give you this, and they're gonna ask you give me what is the y equal to. What is the function y? Okay? So you can solve this by three ways. We can solve DE is different equation, okay? Differential equation in three ways. It's not that hard, okay? Just know it, but you not really use all of them. Answer practically. Separation. I don't know how to spell it. Separation of variable. This is the most effective one. Okay, the number one. It's the most effective one. That's what we're gonna learn today. Second is numerically.
What is numerical?
Euler method. How many of you heard about this?
Euler?
Euler method?
Euler?
Euler?
Is that the one where you like do it?
Yeah, the series one. Series one.
Oh, never mind.
Yeah, you no? You remember Euler? You remember that guy?
Who is Euler? I only know.
Euler, the who invented the number?
Euler?
Yeah, who invented the letter
Was it the E sign?
the number E?
Exponential?
No.
In ham, you took in ham, remember?
Oh, the
2.72 something, special number.
Ah.
Yeah, Why is E here? Because log E is
E.
log E is 0.
It cancels out.
Log of E is
2.9.
no log E.
Oh, I can't see.
0. 1 over x.
1 over E.
Infinity. 0.
Okay, log base E is ln.
Mister, I've been saying
I
that.
I know, but I just heard one person. I want everybody.
No, I said that too.
And then ln E is ln E is.
No, not Mr. You got J's man. Log.
I know. I want everybody to say it. I just had one person. ln E is. Huh? ln E is
1 over E.
is 1.
Oh my, over E.
Only check 2. Only one person.
I didn't win this.
You did. You didn't him. I had you.
Oh, I forgot him.
All I remember from Ham was the unit circle.
I only remember fractions. No, the freaking like solve for 0 the different ways.
Have you heard about Snowfield?
Oh, is it that weird thing?
Yeah. They have a slope field. They go like something like this way.
The one thing that's not gonna
Yes,
be
I
on
know.
ever.
Okay, yeah.
Oh, because you hate it because you don't understand it. But if you don't understand it, you're like, it's gonna be here on
The
clip.
choice that was not on the English exam at all.
It will be on the same note.
Can we go back to disc method and washer method? I like that one.
Yeah,
I like that one.
it's good for sure that we're on the test. Oh, every year I saw at least a few questions about what's this either MCQ or FRQ.
Mister, will you be proud of me if I fail the test but I get the disc washer methods right?
Sure, when you fail.
But what if they say, oh, he knew that. He knew unit 8, so we'll give him a 5.
At least if you fail the BC, you can pass the AB.
What if I fail both?
Then you also fail my class too.
You go back before AB. What is before AB? ZY. You go to ZY.
So when they ask you to solve this, they're gonna ask you 2 ways. Okay, they're gonna ask you a general solution or a particular solution. The thing is, they don't say that. You just need to know. Need to know. Yeah.
What?
So what is the sign? This will be general solution. They won't give you initial condition. Okay. No initial condition.
What does that look like? What is an
Initial condition like C0 equal to 1, like the starting value,
Oh.
right? There is constant C. Like you don't know anything about the initial condition, initial value. Like constant C. When you remember to check the integral, you have a C. Yeah. That you don't have any information. And then they ask you to solve for it. That means they ask you to solve for general solution. Okay? But if they are kind enough, they're gonna give you some information. That means they ask you to find a particular solution. But that also means you're gonna have more work to do with this. So if they don't give you anything, that's actually good. That means you don't need to do any particular solution. Okay? Trust me, I checked the test from year to year. They always have the question. Some year they have like 5 questions. Some year they have like 7 questions. Some year they have 3 questions. At least, minimum. So they always have this. Okay? Yeah, check.
So, is there a constant C for general solution?
There will be constant C. Okay? C, because you don't know the initial condition, so you need to have some constant. So particular solution is when
Do give you an initial
yes,
condition.
they provide the
constant.
initial condition. Do you have C? No C then, okay? No constant C. Why no constant C? Because you have enough information to find the initial condition. Let me write it again. I have a feeling your brain, you know, when you go to the gym, the muscle is gonna build up, right? I feel like your brain also like build up now. You're catching up. You're catching up faster than before. Faster than at least you're faster than last year. Last year is your face. This year you're like, oh yeah, no question, yes, right? You're catching faster. I just give you a sample, it's not specific, but I give you a sample.
And Mr. Just wait till we go to the boards.
Huh?
Just wait till we go to the boards.
Oh, you want to go to the board?
We go to the board and we're just all in.
All right, solve. Let's do some very, very easy one.
I don't like it when you say that. Then when I
Oh,
can't solve it, I feel
fundamental
bad.
one.
No, I feel bad when I can't solve it.
Middle school one.
Does that say
Not middle school. Solve dy with x equal here. That's mean they want you to get y equal to something. That's mean. Okay. That's mean get y equal to fx. Okay. That's what they want.
What is it? Oh, we're doing an example.
How do you do that? That's good. That's a good question.
How do we do this?
Yes. What do you think?
I always think
is it y squared over x? Oh, it's x squared. Oh my. Y x.
Can you go back to the example again?
There's no example though.
There's no?
This is the first example.
Mr. You separate the x squared.
Right. Okay. Remember the very first technique that I put a star here? The most efficient one. We haven't learned Euler yet. We're gonna learn Euler maybe next time. Next lesson.
Next year.
Separation of variables. Okay? First, keep this in mind. You want the y go with
The y.
dy. And the x go with dx. That's it. That's the key.
So can we just no,
Yeah?
it's more. It's
So how do we do that then? If from here. How do I get the y go with only the y and the x go with only the x? What I'm gonna do here?
multiply by y.
I multiply both sides by y square. Okay. You can multiply by dx or y square either way. Okay. Let's do y square because that's what I heard. Multiply both sides by y square. Right. Then what do I have? Dy times y square equal to x square times. Oh, you still have dx. Okay, you still have the dx. Let's do just one by one. You want to cancel out, right? Now what next?
then do the same thing for the
Same thing. You're gonna multiply both sides by dx. All right. So now multiply by dx. You can also do both at the same time, like multiply both them by dx y square if you like. Get used to it. Okay. So now I have y square dy equal to x square dx. Right? Are we good so far?
Yes.
Yeah? What I do is I just isolate y go with dy, x go with dx. Yeah? Yes? Give a thumbs up if you following that. I'm not losing anyone, yeah? Okay, good. Now how do we undo the d? Only one person.
Antiderivative.
Oh, okay, and now two persons.
Integral.
Antiderivative.
Integral.
Now three persons. Yeah? D does mean the derivative.
Oh, the derivative.
So antiderivative, that's what we're gonna do. That means we're gonna take the integral. Yeah, I heard 4 students got it. Like 5. That's it. That's the key point. Very easy, right? Do you know how to take the integral of y squared? Which is y cubed
Over 3.
over 3. Very good. Do you know how to take the integral of x squared? X cubed over 3. Is it good so far?
Yeah.
No. What? It's not
Oh wait. No,
No,
plus
you're
C.
missing. You're missing
Plus C.
the.
Plus C.
Oh no, the integral and d they cancel out, right? The antiderivative of d. They're missing what?
Plus C.
Plus c.
Plus C.
Plus
It's
c.
indefinite. It
Alright.
doesn't give us somewhere to
Don't,
where.
don't forget clearing. His friend.
What?
Yeah?
Wait, Mr.
Imagine someone read a lot, they don't understand what the heck going on.
Jared was asking.
Yeah, Jake.
So the C doesn't go with the light too.
So yeah, good question.
He's be like,
You should have a C over here, right? Right. Okay. Very good question. Very good question. You should have C1 here maybe and C2 over here. But what is C? Some number.
Constant, yeah.
What is C?
Another
Some
constant.
number. Can we combine the two number into one number?
Yeah.
You can, right? So you can just write one C. Yeah?
What am I forgetting?
Okay. Why one C again? Let's say if this one is 5 and over here you have -3. Do you agree with me that we can combine them?
yeah.
Right? You can subtract 5 both sides, right? So you can combine them to have only one -8. Same thing here. Same thing here. If I have C1 here and C2 here, I can minus C1. So I have C2 minus C1. It's just another C. Do you agree?
Yeah.
It's just any number. We don't know. But it's just a number. So instead of writing C1, C2, I can just write 1C. Make sense? Very good question though. Very good question.
But we still need a y by
Right.
itself,
You still need. We're not finished yet because you still need to get the y by itself. So how do I get y by itself? You times 3. That's good. That's right. Very good. So y cubed equal to x cubed plus. Do I write 3c?
No, just C.
Yeah.
No, just
No
C.
need. You just need to write
C.
c because it's just any number. It can be any number. It can be 1 billion. It can be -5. Can it be 0?
Yeah. No.
Well, it can be 0, but then
It's 0.
it can be
Yeah,
0.
it's
We don't know.
constant.
We don't know yet. It possibly. But if it's 0, then we can just delete it. But we don't know yet. Okay, so just put it there. And then how do I get rid of the 3? Like Omar just said earlier. You're gonna take the cube root. Do I have the plus and minus?
No.
Why not?
Odd.
Because odd power. Good. You still remember. But you forgot the log though.
Oh, it's supposed
I
to
checked
go
the
like
log a little bit. I think a lot of you forgot it.
What love?
They asked the member worksheet of log. They asked you to expand it. For example, they asked you to expand this one. How do you expand this?
I don't know.
Log 5 plus log
Oh.
3.
Oh, yeah.
A lot of people give me log 15. I know 5 times 3 is 15, I know. But the question is asking you to expand it, right?
Yo, that might have been me. Yo, that might have been me.
Easy?
Yeah.
Yeah? For now?
That's not bad. But it's not bad, but it was also a very basic one.
Is this general solution or particular solution?
General.
General, because you don't know anything about initial condition, right? And then that's why you must have a C. Now I'm gonna using the same question here, but I'm gonna ask you to find the particular solution. They're not gonna say that. They're not gonna say particular solution, but they're gonna give you something like this. Oh, actually, sometimes they can say it too. Let's write find the particular solution when x equal to 2, y equal to 1.
Thanks.
This is initial condition.
What part of the pancake?
I wanted water.
We need a Shakespeare.
So x is
Like?
equal to 2 and y is equal to 1? What is y equal?
This week? The
What is y
Shakespeare.
equal to?
Shirley, she knows.
What
When
is
the
y
Shakespeare
equal
play,
to?
Shirley?
One. Oh.
Is that this week? The
Haven't come in?
Shakespeare one?
No.
The play?
It's April 10th.
Oh, okay. So next month.
There's 2 performances. I can
We're
like
going?
translate this like
I will go. I watched it last year already. Is that the same thing?
What?
No, Shakespeare performance.
Oh, wait, so what was our equation again? dy over dx
Yeah,
over
sure.
x squared over y squared, right?
Okay.
Yeah.
All right. How do you find a particular solution when you notice that this is the initial condition? You plug it in. That's it. Okay. You plug it in. Why would you plug it in?
Oh, so explain to you.
Plug it in to find
See.
the C. That's it.
Oh.
You plug it in so that you can find what is the C actually. Okay. X is
X is 2.
okay. Plug into the X. Y is
1.
you plug into the Y. Then you can find the C. Right. So let's plug it in. So 1 equal to cube root of Notice, I put the C inside the cube root. Okay?
They ran more.
C is not outside the cube root. Well, you may ask me, oh, but mister, did you just say C is constant, then cube root of C is also constant, right? But the operation is they still need to be inside the cube root.
They
Right?
learn
Because you're taking the cube root of the whole thing.
Morse code over algebra is crazy.
Yeah. Mister, look.
So then it's just.
They cheated Morse
They
code.
have Morse code in the calculator.
Oh, Morse code.
Hello.
They do anything to cheat in your class.
That's freshman. Yeah. I caught a lot.
Dude, you're cheating in.
They put on the chair, they using the phone on the backpack.
What?
They write on the name pen.
Wow.
But then none of them get away though. I can tell. I can read people. I can look at their face and look at them. I can know. Because I mastered of it too.
Yeah.
You're
Remember I
a
told
master
you?
of cheating?
Remember I told you I used to cheat when I was middle school? Yeah.
No.
I even know more trick than you.
What tricks do you know, mister?
A lot. Even on the pen as well. A lot. You
Wait,
put
mister,
some,
what do you know the...
small paper on the pen too.
What do you know
But that's
about
in middle school. I cheat when I was biology class or
There's the cheating inside the
sociology
pen, bro.
class. Middle school. That's a middle school kid.
Wait, mister,
Go
wait, you
judge
didn't have meta AI classes though.
Huh?
You didn't have meta
So what
AI
does that say?
classes.
X squared
Expensive
plus
though,
C?
right? I don't think a student can afford it.
C equals negative 1.
I want to get one so bad.
Can you solve for C? Is anyone got the C? C equal to negative 1? Okay, let's check.
And we can
So you're gonna power 3 both sides, right? Power 3 both sides to cancel the cube. So 1 equal to 2 cube plus C. So 2 cube is 8. So C equal to negative 7. Right?
Oh. I did something wrong.
How did you get a negative 1?
I took the cube
You got that one
inside
too?
first.
Oh,
I took the cube inside first, and then I did the
Oh,
cube
yeah,
root.
first. Damn it.
You need to cancel outside first, by cube first, to cancel this. Right? This is algebra. This is algebra 2. You were in hand.
That's cheating.
Morse code.
I still have the picture when you were in my hand. I still have that picture.
Oh.
Hey, Joshua, put that in your backpack.
Morse code.
Morse code.
So y equal to, you need to get the final answer though. Y equal to cube root of
Oh.
3x cubed
s cube
plus minus 7.
minus 7. That's the particular solution. Okay?
Oh.
Mister, so for the particular solution, you have to do the general to find the equation, and then you plug in the
Right.
numbers?
Right.
Okay, maybe it was a hard problem.
You want to on the board?
Yeah.
Okay, let's go to the board, do it. I'll give you the heaviness, okay? Assemble 2. Huh?
Just so you can write it down on the post-it, these are the performance centers.
Oh, okay. So you only have 2 performance?
Yeah, for school. I have one at the school, but like,
So first day, 11 would be period 4 and period 4 and period 5. Thank you. And let me take a picture. Let me take a picture. Yeah. Yeah. Now what next then? You click integral. Okay. Now what is the integral of 1 over y dy? M and y. What is the integral of this? When you see the derivative of one is the other one, we have been doing this like a lot. Practice, right? You're gonna use Euler. Let u equal to x squared plus 4, du equal to 2x dx. So that means dx is du over 2x. So I'm going to replace the x here by du over 2x. You can also see x dx is du over 2. But just to be safe, we're going to do this way to be safe. So x over x squared plus 4. I mean this one becomes u already. So u here, right? So and then x cancel out. So ln equal to du over u and 1/2 on outside. I move the number 2 outside. So what's it good? Yeah? Okay. Now what is the derivative of du over u again? Same thing as derivative of 1 dy over y, right? Same thing. So what you get over here? ln u. So ln y equal to 1/2 ln u. But what is ln u? Thank you.
X squared minus SSC4.
Oh, Emily gone for the rest of the period?
Yeah.
You need to replace the u, right? Let me write another separate line so you can don't be confused. Equal to 1/2 ln of x squared plus 4 plus c. So what's good? Is that what the answer they're looking for? No. You need to get y by itself. How do you get y by itself? You need to cancel the ln.
E.
You're gonna take the e. Okay, did you learn that in him?
Yeah.
Yeah. No?
We learned it in last year.
Oh, you learned AB too?
Yeah.
Okay, so but actually it's one we learned in him as well. If you
Oh, I don't remember.
because e to the power ln they're gonna cancel out, right? So now e and ln cancel out, so you have e. Oh, you have y.
Mister,
Yeah.
for the ln, do you do chain rule with the x squared?
ln here?
Like, you know how it's ln x squared plus 4? Do you do chain rule with
Oh no, when we do the u sub, there's no chain rule anymore because it's already taken care of that. The chain rule happen right here, the two right here. So when you do, but that's a very good question. When you do the u sub, there's no more chain rule. Because u sub take care of the chain rule for you already. Yeah, that's very good question though. Very good, very good. Do you see the 2 here? Now the chain rule happen. Right? What is the derivative of this? 2x, right? The x cancel out with this already. And you only have 2 left. That the chain rule only happen. Yeah? Very good question. Now, can we cancel the e and ln here? No. You can only cancel when they like next to each other like this. So you have something in between. You cannot cancel that yet. But how do you get take care of this guy? How do you take care of the 1/2? Property of log is the power. You can bring the power to the front. So now the number in the front I can bring back to the exponent, to the power, right? So I need to bring this guy back to the power. So e to the ln x squared plus 4 1/2. Well, I know x squared plus 4 is positive, so I can just change the absolute value becomes parentheses. Yeah? So what's it good? Plus c. C in the power though. C in the power. Oh. Something missing. Okay, anyway, are we good here? Now can we cancel the e and ln?
Yeah.
Yes, right? Oh, we have 2 minutes. Always. So x squared plus 4. What does 1/2 mean? Square root. Okay, so can I just put the square root here? Oh, remember c is in the power. When the power is plus, what does it mean?
What?
When you add the power, what does it mean? Can I break this one? Can I write like this? Can I write like this? No. Like what I mean is after this is period 4, right?
Yeah.
We can continue tomorrow because a lot of people want to talk about this. Okay? So yesterday we learned about the differential equation. Remember there's a lot of question. Actually a lot of questions is about differential equation on the PC test. So you should know how to do this. two types of solution, which are particular solution when they give you the
C.
initial condition, and there's no
C.
C. Okay, and if they don't give you the initial condition, then you're gonna, what kind of solution is that?
General.
General solution. No initial condition. There will be constant C. The way to solve it is to get dy and dx on two different sides. Okay, and isolate y go with dy, x go with dx, and take the integral. And then yesterday I think we do a group, but we solved it right here. Right? That's the tricky part because plus C right here is on the power. How do you bracket?
Didn't we do this one?
Oh, we never finished.
We never finished this one, yeah.
I thought
So
we
you
did.
want to have two E's.
Okay, E and LN đấy. Cancel out. Right? So you're gonna have y equal to, well, you cannot cancel E and LN yet because you have 1/2. How do you bring the 1/2 to move it? So you're gonna move it to the power. So you're gonna have E ln x squared plus 4 1/2 plus C. Remember, C is part of the power. Okay, C is part of power. How do I break the C out? How do I break the C out?
E and then E
Huh?
plus another E.
So E, tell me what you write. E ln x squared plus 4 1/2
Plus
plus
E.
EC
There.
plus C
Oh, yeah. C to the E.
plus C to the E power. Oh, even more creative. It's okay. It's okay. Anything else?
Plus
What do you think?
LNC.
So far, it's nothing. No one is right yet.
LNC.
Where does it come from?
Plus.
LNC. LNC.
Plus zero.
Oh, C to the 1/2.
C to 1/2. Keep going. Let's see how creative you
Square
can go.
root.
Square root of C.
Absolute value of C.
You just take
Square
out.
root C.
Huh?
Square root
Square root of C. Now we're getting more crazy. What else?
Derivative of C.
The inverse of C.
Huh?
C to the power of square root 1/2.
You see how damage it went absent one day? Just kidding. Make sure we want to delete that. Just kidding. Just kidding.
I C to the power of C.
Okay. X. No. Just you. Any guess? Any other guessing?
C inverse.
3, 5 plus 3. How do you break? Yeah. No silly question. Just any answer.
Oh, then just
X to the power of 5 times x to the power. I mean x to the power 3 x to the power 5.
Okay, so
Yeah,
you
right?
multiply by C.
So how do you practice?
Times
Times E to the power. Is anyone said this?
Didn't we say that?
I only said
So, yeah, sometimes I heard one person, only one person, so that's why I want to wait for everybody to.
I mean, basically.
Yeah, sometimes I heard Jay said that too, Clay said that too. Sometimes Melissa Labu said that too. Isabel. You know, like now. Oh, Isabel, you have anything on this question? I actually upload the video of this because yesterday I had 2 absences, right? Isabel and who? And
Emily.
Emily. Okay, Emily left. So watch it. Watch the video. Okay. Now, the E to the C. Can we just write
C.
C because it's still a number, right? So you're gonna have E ln. I'm going very slow here. So E times C. So what's good? Now E to the ln, when we cancel now,
Yeah.
right? Because they're next to each other now, you can cancel it. So now you have x squared plus 4. What does 1/2 mean though?
Square root.
Square root. Square
Yeah,
root,
we
right?
did this
Well, we can actually take out the absolute value. You know why?
Yes, we did.
Because you're gonna have negative.
Because I had it. I had the fun one.
Why can we take out the absolute value?
There was no two numbers. Wait, what?
Because
Remember, I was
x squared plus 4.
when I was looking at my
Huh?
video.
They're always positive, right? something square always positive, and then you add 4 is always positive, right? So that's why you don't need to worry about absolute value because they're always positive.
But even if you write it with it, it doesn't matter. It's still right.
Yeah, it doesn't matter. Yeah. Times C.
Like this?
Yeah, so what's good?
Yeah.
And then? And then, what's the answer?
Just get them.
Just one more.
Just take the whole bag. Take the whole bag.
Yeah, I had this. I erased it because I thought it was wrong. When did I stop it in my sleep?
Okay. You want us to
Wait, what are we doing now?
Oh,
Are we
you
solving
take like
things?
6.
Mister, are we solving things now?
No, you're solving for y. Are we done yet? Because no, we're not done yet because you have the absolute value.
Really?
How do you get rid of the absolute value?
No, I can't.
Yeah, they don't get too complicated. How did you get rid of the absolute value?
You absolute value it again. And it cancels out nothing.
Right?
What? Wait, what is it?
Okay.
Okay, now go back to middle school.
Okay, whatever.
When absolute value of x equal to 7, how many solutions you have? 2, right? X equal to 7 and x equal to, right? Or you can write plus minus 7, right?
Ooh.
So same thing here.
That is square.
Because this is absolute value of y. If you want to get rid of absolute value, you need to have plus and minus. But now this is another thinking. Plus c and negative c. They still c. So you can write right, but it cannot be the same c here. So you can write a c1 or something, or any number you want, any letter you want. Just saying that this is not the same as this c. Make sense? So that's calculate they're very detailed on this. Okay. So y equal to this. That's your answer. That's why I don't want to rush through it
Wait, no.
from yesterday, right? So
Wait, don't we have to find
yeah. Any question?
Can we do another one?
Oh, C1 because I don't want it to be the same as C, this C. So I'm using another letter. You can use it like K or J, any letter. I just put C1, so different from C here. Yeah? Because, okay, let me note here. C1 is not the same as C. That's the reason why. Yeah? Let's do another. Okay. Oh yeah, one more. Yeah.
Isn't this one particular? The one that we just did?
I think, yeah.
Like, isn't it particular?
Particular is when they give you initial condition, right? Did they give you any initial condition? No, right? That's why you still have the C. So if you have an initial condition, then you don't have the C. Okay? Yeah, good question.
Oh.
You know what?
We're good.
Hey, you really did it. Yeah.
in school?
No, I mean like.
Hell no. It's like,
Yeah. No, it looks like I just told you.
Alright, you can do on the whiteboard.
On the whiteboard or
On the
board?
roof, yeah, on the roof. Whiteboard. Y prime, we need to have dy dx, right? Y prime is dy dx right here.
Yes, sir.
So we want one side to be dy, one side to be dx. Doesn't matter which one on left or on the right. But you don't want 1 over dy or 1 over dx. Okay, you don't want this. So that's why if you see this right here, then you need to move the dx over here. So they're both on the top. Okay, so that's what you're gonna do. So I'm gonna move dx over here. I have dx xy equal to e negative 2 y squared minus 1 dy. Yeah? And then what? Now I need to bring everything involved to the x on one side with the dx, everything involved to the y to be one side with dy.
divided by 1.
Divided by y. Okay, divided by y.
Why? But why?
But why? Because we want y to be on one side with y. So that's the reason why.
That's a lot of lines.
Yeah.
Why?
Why we have a lot of y. Now this one is still have the x, so I'm gonna bring this one over here as well. Right? But the the negative is on the bottom already. This is okay, we're gonna divide this. So now I have x over e to negative x squared dx equal to y squared minus 1, everything over y dy. I think we achieve our goal, right? Everything with the x on the dx, everything with the y on the dy. Correct? Now, negative power, we don't want negative power. So how do we take care of the negative power? You're gonna flip it. So it look like e x squared times x dx equal to y squared minus 1 over y dy. Okay? Now, because dx, everything with the x, and dy, everything with the y, we can take the integral. Very good. You see how important of the unit we spend a lot of time about the technique? Because that's what we're gonna apply it on the later units, right? You learn about integration by power, partial fraction, u sub, trig integral, whatever. But this one, which method you gotta think about? U sub. Whenever one derivative is the other one, then you're gonna u sub is the best. So I'm gonna use in the u sub right here. Okay? U sub. Let u equal to x squared, or you can also let u equal to ex squared. The same answer. So x, I think x squared better. So dx equal to 2x. I mean du equal to 2x dx. So that means dx is du over 2x. Right? Yeah. Then I have e to the power x squared. X squared is u. So eu times x. And dx become du over 2 dx. The x and x cancel out. So now I have 1/2 eu du. Right? Yeah? Okay. Now, how do we take care of this guy? You're going to break it, right? That's a fraction, so you're going to break it. So y squared over y minus 1 over y. What is y squared over y? Y. So you have y minus 1 over y. Both of them we know how to take the integral, right? What is integral of y? Y squared over 2. What is integral of 1 over y? Ln y plus c. Right? So this is y squared over 2 minus ln y plus c. And this one going to be 1/2 eu. Right? Integral of eu du is just eu. Because this is corresponding, they're the same. So I need to replace the u though. What is the u? X squared. So 1/2 e to the x squared. Do you wonder why I only have one c? It's supposed you have 2c on two sides, right? It's supposed you have like c1 and c2 here, but because it's still constant, so I can make them into just one c. Yeah. All right. Now from here, you actually can. Isn't it easy to solve for y? Isn't it easy to solve for x? It's possible, but it's going to be a lot work. So sometimes they can also accept it to stop right here. Okay? Only if they give you the MCQ, they give you some answer, and you can check it. But it's reasonable. You can stop right here as well. If you want to solve for x, that's possible. You're going to multiply by 2 everything, right? Then you're going to take the ln both sides, correct? And then you're going to take the square root everything, right? So if you really want to solve, you don't need to know, okay? But if you really want to solve, and then we're going to take the ln both sides. So we're going to have x squared equal to ln extra. Okay, this is extra. So now you're gonna take the square root.
The thing
Mommy,
like the cowboy.
Yeah, that would be the answer, but usually you can stop right here. Okay?
Why is the cowboy right at the top?
So it's extra, you can give us an extra point?
Yeah.
Okay.
Last question, last sample. What time we done now? 51?
Are we going?
Huh? You can stop right here, but if you sometimes if they want to really solve for either x or y, then you can go further. Solve for x easier. So x is gonna be this. Oh yeah, I forgot that. Yes, thank you for reminding. We have the initial condition though. Y0 is 1. Okay, so from here. That's right, that's right.
So we do it.
Y0 is 1. That means x is 0, right? You're gonna plug it in first, but sometimes you can have some number over here as well.
Wait, what?
When x is 0, when you plug it in, what do you have? So 1/2 times e to the power 0 equal to y is 1, right? Y is 1, x is 0. Correct? I plug it in. Y squared 1/2. Yeah, Labu. Labu, you know what we're doing now? Don't give up. Don't give up. Okay? Don't let just check out. You know what we're doing?
Yes.
What we're doing?
Well, like, I know.
Yeah, so we're gonna block in the initial condition. Okay? Y of 0 is 1. That means x is 0. Y is 1. So whenever I see x, I'm gonna put 0. Whenever I see y, I'm gonna put 1. Okay? What is ln1 though? 0. So you see, then not c is not really depend on this one, but you need to plug it in to see the c. E to the power 0 is 1. Everything to the power 0 is 1. So 1/2 equal to 1/2 minus 0 plus c. So c actually equal to? C equal to?
1/2. Wait, what the? Yeah, 1.
I feel like you keep stuck in it until like
0?
I start asking very easy question, you still not want to, you don't know an answer.
Automatic.
0?
Like you get used to it, like I don't know how to answer.
It's 1. It's
1?
No.
No, it's 0.
0.
What's up with you? You have
1/2 cancel out, right? You see 0.
It cancels out.
So C is 0.
I thought you had to move
Right?
it.
1/2,
That's
1/2.
why. And then one will turn negative.
You subtract both 1/2 both sides. Yeah? So C is 0. So the final answer is no C.
No, because they're both positive, so if you move one to the other side.
Oh.
Right, you move to the other side and then they cancel out. Or you can see that if you have the same answer, both sides, you can cancel out.
It's just, I don't know what I'm doing. I think I'm thinking about variables. Like, why? I think I should get to. We thought of doing
Is that too hard or something?
Yes.
No.
It's not too hard.
We're tired.
It's not too
It's
hard.
just complicated, so I really messed up like on the way.
You should put 2x dy dx on two sides, right? And then just take integral. It's not too hard. All the technique we learned already. If you struggle with this, the next 2 unit is only for the VC. So imagine the next unit is more complicated. Yeah? Don't give up, okay? Don't give up.
So can we use the class?
We need more support.
Yeah, we have it. Can I teach you?
Yeah, you don't have to. You just have to see. There's only 15 minutes.
Mr. Can I say this again?
I don't know. No, I know.
I want to say
Oh, I hear it now, I hear it. We're like up and down.
because daddy's like.
How about this? Get the paper, do it right now. I'm gonna collect it. So you're gonna take it serious. I think you check out already. I'm gonna give you the blank paper. You're gonna do it. I'm gonna collect it. Okay?
What seriously, I'm gonna
I think you on the mode you check out. You relax.
Can we use our notebooks, please?
Wait, that's the test.
You're gonna give us.
I can help you, but I want you to take it serious. So slope is dy over dx, right? And the slope is equal to this.
Y.
So that means dy over dx equal to y over x squared. That's another way they can ask you, right? Another language they can use. Or they don't give you the function, but they give you what the slope equal to. And what do you think the point here gonna give you? What kind of information is this? Are you going to find general solution or particular solution? That's right. So using very basic question. Okay, very basic question.